Hi, this is Rowan Miller. In this video, we're going to look at creating a CodeFirst model that maps to an existing database. If we look at my local DB instance, you'll see that I have an existing blogging database that we're going to map to. If I open it up, you'll see we have a posts and a blogs table. And if I expand each of those, you'll see they each contain a few simple columns, and there's also a relationship defined between the blogs and posts table. Let's swap to Visual Studio. I'm going to start by creating a new console application. Once our application is created, I'm going to add a new ADO.NET Entity Data Model. On this first screen, I get to choose the type of model I want and whether I want to start with an empty model or generate one from an existing database. I'm going to select CodeFirst to an existing database. The options to generate a CodeFirst model were introduced to this wizard in EF 6.1. So to use this functionality, you'll need to have the Entity Framework 6.1 tools for Visual Studio or later installed. The first thing we do is specify the connection to the database. So I'm just going to enter the details for the blogging database on my local DB instance. After that, we get a screen where we can select the tables that we want to import. So at this point, I could import a subset of the tables in my database. But for this demo, I want to import both the blogs and the post table. I then click Finish, and the wizard is going to look at the shape of my database and generate the corresponding CodeFirst model to allow me to access the data from my existing database. Let's take a look at the artifacts that it's generated in my project. First of all, if we look in the app.config file, we'll see that it's introduced a new connection string. The connection string is called blogging context, and we'll see where that name is used in a second. And if I look at the details of the connection string, it points to the blogging database on my local DB instance. If we swap to the context class, we'll see that it's generated a derived DB context. This class represents a session with the database and will allow us to query and save data. If we look at the constructor, we'll see it's passing name equals blogging context to the base constructor of DB context. This is telling DB context that it should use the blogging context connection string from the config file. That's the one we just saw. On the context, we've also exposed a DB set for every type in the model. This will allow us to query and save instances of the types in our model. In addition to the context, the tooling has also generated a class for each table in our database. Let's look at the blog class, which corresponds with the blogs table in the database. The first thing you'll notice is that these are simple classes that look close to what you might write by hand, and they have no dependencies on Entity Framework. These are known as plain old CLR objects, or POCO for short. By default, CodeFirst can infer a lot of things by convention. For example, the primary key of the blog class is called blog ID, so Entity Framework will automatically detect that that is the primary key for this class. So in this case, no additional configuration is needed. However, in some cases, what CodeFirst would detect by convention differs from the configuration in our database. For example, you can see here the string length attribute is applied to some of the properties to let CodeFirst know that the maximum length of this property in the database is 200 characters. In some cases, there will be configuration that needs to be performed that cannot be done with attributes. In these cases, the wizard will generate code that uses the Fluent API in the onModel creating method of your derived DB context to perform this configuration. In our case, however, all the configuration could be done using attributes, so the onModel creating method is currently empty. Now that we have a model, let's write some code to perform data access using it. The first thing we're going to do is create an instance of the blogging context. Blogging context implements iDisposable, and therefore we're wrapping it in a using pattern to ensure that any resources created by the instance of blogging context are tidied up and disposed of when we're finished with it. The first thing we're going to do is prompt the user for a name for a new blog. Once we've read back the name that the user has entered, we're going to create a new instance of our blog class assigning that name. We'll then add it to the blogs DB set on our context. This lets Entity Framework know that when it's time to save changes, we want to insert a new instance of the blog class. With that done, we'll call Save Changes, which will cause Entity Framework to push all the pending changes to the database. In our case, just inserting the single instance of the new blog. Now let's query back from all the blogs from the database ordered by their name. We're then going to go through each of the blogs in turn and write the name of the blog out to the console. Finally, at the end of our application, we'll just insert some code to prompt for a key press to exit, just so we can see what's happening on the screen. Now that we've written a simple application that performs data access using our model, let's run it and see it in action. As expected, we're prompted for a name for a new blog. I'm just going to enter ADO.NET blog. After that blog is saved to the database, we'll see that all the existing blogs from the database, both the one we just inserted and the ones that were present in my existing database, are displayed on the screen. In this screencast, we saw a brief introduction to using CodeFirst to map to an existing database. For more information on this scenario, visit the URL displayed on the screen.